International Symposium of Engineering Application on Civil Engineering and Earth Sciences. In advance, I would like to express my special thanks for your joining. I hope we have a great day, like yesterday also. For the first keynote presentation, I would like to invite actually Prof. Dr. Sinan Nihat Işık. After actually giving a short information regarding Prof. Dr. Nihat Sinan Işık, I would like to invite him to start his valuable presentation. He actually, Prof. Sinan Işık graduated from Middle East Technical University, Department of Geology. He started his master's education in the field of applied geology at the Department of Geological Engineering at METU. In 1998, he started to work as a research assistant at Gazi University, Faculty of Technical Education. Part of the Soil Mechanics Laboratory at Gazi University. After completing his master's education, he started his PhD in applied geology at METU Geological Engineering Department. He completed his doctoral thesis named Experimental and Numerical Investigation of Pressure Experiment in 2006. In the same year, he was appointed as assistant professor to Gazi University Technical Education Faculty Building Education Department. In 2011, he received the title of Associate Professor in Geology. In the same year, he was appointed Associate Professor at the Gazi University Faculty of Civil Engineering. He has been working as a professor in the same department of expertise are engineering geology, soil and rock mechanics. Presentation for our today's actually season. We
Professor Chairman, I couldn't hear you.
Yes. No, you can hear me?
Yes. Your voice is clear now.
Yeah, please, I would like to actually invite you to start your valuable presentation, please.
Thank you, Professor. Dear participants,
You're welcome.
I hope you can see my screen, my presentation.
Yes, everything is ready.
Okay. I'm going to present the topic of basin effects on earthquake ground motions. First, I would like to briefly discuss the ground stability problems during earthquakes. The first one is fault rupture-induced ground deformations. The second one is earthquake-triggered landslides. The third one is liquefaction phenomena, which occurs during earthquakes in sandy soils, loose, sandy, saturated soils. And the last one is a very important phenomenon, which is called as soil amplification, effect of vibrations. Most of the damage during earthquakes is due to soil amplification, actually. Ground motion at a site is due to a combination of source, path, and site effects. Here in this figure, you are seeing fault rupture process. This is called a source effect, which is due to stress drop, rise time, irregularities on the fault plane, etc. The second effect is called as path effect, which is due to wave propagation within the crust and affected by seismic and geological structure of the crust. And the final one is called as site effects. Site effect, the effect of near surface soils and young sedimentary rocks on earthquake ground motion. This phenomenon is also called as ground response. Here in this figure, as an example ground motion record, I'm going to show you the Kahramanmaraş Pazarcık earthquake recorded at Hatay 3142 station. First one is acceleration time history. The second one is the integration velocity time history. And the last one is the displacement time history. These records are in the time domain, but we can transfer these time domain ground motions to frequency domain using a fast Fourier transformation technique. And this plot is the Fourier spectra of Kahramanmaraş Pazarcık earthquake, Hatay 3142 station, east-west direction. By using this Fourier amplitudes, we can investigate the frequency content of ground motions. As I have stated previously, local site conditions affect ground motions. The first plot, which is on the left, shows the maximum acceleration in rock versus maximum acceleration in soft soils. As you can see from this figure, up to 0.4 g, rock accelerations are amplified by the soils. However, beyond approximately 0.4 g, accelerations in rock de-amplified by soft soils. The graph, the plot at the right side shows the effect of soil types on calculated response spectrum. The blue line shows a typical response spectrum recorded on a rock type of geological medium. And the red line shows the typical response spectrum recorded on soft soils. As you can see from this plot, soft soils increase the period content of the ground motions, amplify high period seismic waves. It is well known that surface soils and soft sedimentary rocks can cause significant structural damage even at long distance from the earthquake source. A typical example of such a phenomenon was observed during Mexico City earthquake 1985, which was a moment magnitude of 8.1. Mexico City is approximately 400 kilometers away from the epicenter. Surprisingly, small damage was observed around the epicentral region. However, enormous damage, especially only in a small part of the Mexico City, observed. The geological structure of Mexico City is somewhat interesting. Mexico City was founded on a lake bed, an old lake bed. Actually, it is filled with soft clay soils and bounded by hard and high velocity rocks, which is a typical basin structure, bowl-shaped basin structure. There are three distinct ground motion recording stations. Three of them are shown in this map: Yunnan site, SCT site, and CDAO site. Yunnan site is a typical rock site and which is very close to Mexico City. SCT and CDIO stations are founded on soft clay soils of Mexico City. This upper acceleration time history was recorded at the epicentral region. Maximum peak ground acceleration near to the epicenter is about 0.2 g, and ground motion is rich in low period waves. Whereas Yunnan station recorded an approximately 0.04 g maximum acceleration with a maximum ground velocity of 10 centimeters per second. However, SCT site, again I should remind you, which is approximately 380 kilometers away from the epicenter. In SCT site, maximum ground acceleration is about 0.2 g, and ground motion is rich in high periods. You can see from the bottom plot. And this plot shows the response spectrum of recorded ground motions during this earthquake. Epicentral region is indicated by dashed black line, and Zone C, SCT site actually, is drawn by the purple line, purple column. As you can see from this plot, amplifications of certain periods may lead to partial resonance of structures, and around 2-second period, there were high amplifications, high spectral amplifications. Buried valleys and basins are structures having lower density and shear wave velocity formed during sedimentation, and they are generally bounded by hard rocks with high density and higher shear wave velocity. In such basins, additional soil amplification effects occur due to multidimensional structures. The term basin effects refer to seismic waves trapped in soft sedimentary deposits that also fill convex depressions. Basin effects significantly change the frequency content and significantly increase the duration of the earthquake. Here you can see a typical basin shape, and this one is also a synthetic numerical model, basin model. They are generally convex depressions. Actually, soil amplification is due to a combination of various effects. We can divide these effects as one-dimensional and multidimensional effects. One-dimensional effects are due to impedance difference between layers and one-dimensional partial resonance of layers. Multidimensional effects are due to focusing, defocusing, basin resonance, and basin edge effects, conversion of body waves to surface waves. I will explain them briefly in the following slides. 1D effects are, first of all, due to impedance contrast. When seismic waves travel through hard rock and pass through soft soils with lower density and lower shear wave velocity, short wavelengths, amplitude of the short wavelengths increases due to velocity difference. And the partial resonance effects are due to resonance of discrete layers. Each layer has its own resonance frequency or natural frequency. So waves at these frequencies are amplified. Multidimensional effects, 2D or 3D effects. The first one is the basin resonance. Energy seismic waves are partially trapped in the top layer, trapped within the basin. The second effect is focusing effect, which is due to convex structure of the basin. Here in this figure, as you can see, that part of the basin significantly amplified the ground motions. And the final multidimensional effects is the conversion of shear waves and actually body waves to surface waves. Body waves, shear waves converted to Rayleigh and Low waves. This is actually a video, an animation. This is a calculation, numerical model. Here in this video, you can see a yellow-colored rock layer, which has a shear wave velocity of 2,500 meters per second, and there is a trapezoidal-shaped basin filled by softer sediments. Their shear wave velocity is about 400 meters per second. This is a synthetic case, actually taken from Makra et al. Study, but numerical simulations were performed by our team. I'm going to show this video. However, in this video, deformations are highly amplified, highly exaggerated, in order to clearly see the generated surface waves. I'm going to start the video now. Sorry, I should close the... Okay. As you can see, although the seismic waves are diminished in the rock layer, they are continued to shake in the basin. I'm going to show you again the video. Oh, oops, I'm sorry. Let's watch it again. As you can see, the duration of the quake is increased significantly. Okay, how can we estimate these side effects? I'm going to briefly discuss various methods. Sorry. Okay. First group of methods is called as measurement-based methods. The most well-known one is the standard spectral ratio method.
Sorry, Professor, we can't see your presentation.
We can
you share?
See your presentation. Yeah, please share.
Okay. Sorry for the inconvenience. I'm going to share it again. Is it okay now?
Yes, it is okay. Thank you very much.
You're welcome. The first one is called as measurement-based methods. Standard spectral ratio method of Borchardt, which is the ratio, actually the ratio of the Fourier spectrum recorded on soft soils divided by the Fourier spectrum recorded on rock sites for the same earthquake. This ratio gives actually the transfer function of soft soil deposits. The second one is called as H/V method, Nakamura's H/V method. We can use this method in both ground motion recordings, also in microtremor measurements. In these methods, Fourier spectrum, horizontal Fourier spectrum divided by vertical Fourier spectrum. By these methods, we can estimate the predominant period of the site as well as the amplification ratio. And the third one is the numerical simulations, ground response analysis. They can be performed one-dimensionally, two- or three-dimensionally. Also, they can be performed in frequency domain and time domain. But soil behavior is highly nonlinear during earthquake loading. Both shear modulus decreases and damping increases due to hysteretic behavior of soils. We should consider these nonlinear soil behavior in numerical simulations. I'm not going to discuss detailedly this slide. This slide shows the procedure taken during the equivalent linear method calculations. This figure shows an example soil profile for 1D ground response analysis. Actually, this is from a deep soil program called as deep soil. And this one is quad forum, two-dimensional ground response analysis. This is also an equivalent linear analysis. Here you can see the modeled valley, bowl-shaped valley, and calculated accelerations in the mid of the valley, shown by red line. Blue line shows the rock accelerations. This is another simulation, but this time a nonlinear time domain explicit finite difference method. These simulations were performed by using FLAG 2D software, and these simulations were performed by our team. This is also a synthetic valley filled by softer sediments having approximately 450 meters per second shear wave velocity. This trapezoidal shaped valley bounded by a rock type of material with a 760 meters per second shear wave velocity. Nonlinear behavior of the soil material was considered in this analysis. A Gabor pulse type of acceleration time history was used during simulations from the base of the layer. And here I have selected 3 points, A, B, and C. C is at the middle of the valley, buried valley basin. B is just at the edge, and E is closer to the edge of the basin. In this plot, you are seeing acceleration time histories calculated at point A, B, and C. As you can see, at C, the duration of the acceleration ground motion is increased. Also, a very simple actually time record was used, but at the middle of the valley, this simple acceleration time record becomes much more complex record due to 1D and 2D effects. In this figure, I'm showing you the calculated response spectrum at points A, B, and C. At the middle of the basin, higher periods are amplified. At the edge of the basin, peak ground accelerations are amplified. Lastly, I'm going to talk about some case studies of basin effects, especially observed recent earthquakes in Turkey. First one is Izmir earthquake, which was occurred on 2020, November 2020, which is also called as Samos earthquake because the epicentral region is just at the north of Samos. The earthquake has a moment magnitude of 6.9. This earthquake caused extensive structural damage, especially at Bayraklı region of Izmir city. Bayraklı region is within the Bornova Basin. Bornova Basin is bounded by 2 normal faults and 2 hills. This Google Earth image shows the Bornova Basin and Bayraklı region, where there were extensive structural damage. These recording stations are close to Izmir city center. Some selected ground motion parameters are shown in this map. However, I'm going to discuss briefly 2 recording stations. One is called as Buca station. Its shear wave velocity, average shear wave velocity, is about 700 meters per second. This station can be considered as founded on an engineering rock type of soil. Whereas Bayraklı station founded on soft soils, and Bayraklı station is just somewhat at the center of the basin. As you can see, peak ground acceleration was about 0.04 G at Buca station. Arias intensity is very low, 0.003 meter per second. Whereas at Bayraklı station, peak ground accelerations were about 0.1 G in both directions, and Arias intensity at east-west direction was about 0.353 meter per second. As you can see, both stations are very close to each other, but at the Bayraklı station, significant amplifications of accelerations and intensities were observed. This was due to basin effect. In this plot, ground accelerations recorded at Buca and Bayraklı stations are shown. Buca station's acceleration time history shown by yellow color. Red color plot shows the Bayraklı accelerations in the north-south directions. This graph again shows the response spectrum of Buca, Bayraklı, Bornova, and other stations. But I'm going to show you Buca station, rock-founded station spectrum, and it is green-colored one. I'm not going to open the pointer because screen disappears. Bayraklı region's response spectrum shown in red color, both in north-south direction, dashed red color, and red color in east-west direction. As you can see, Bayraklı station has both higher peak ground accelerations and higher spectral accelerations at every period compared to Buca response spectrum. And the final case history is from Kahramanmaraş, Pazarcık, and Elbistan earthquakes. The recent earthquakes occurred on February, 6th of February. Unfortunately, these both earthquakes caused extensive damage and death tolls around a wider region. However, on Hatay, Antakya, at Hatay, Antakya, enormously high ground motions were observed. This plot shows the geometric averages of peak ground velocities. As you can see, most of the stations exceeded 1 meter per second peak ground velocities. Hatay Amik Basin is also a basin structure bounded by two faults, two horsts actually. There are stations close to basin edge, close to fault, active fault. I'm going to discuss one of these recording stations called as 3124 numbered station, which is somewhat closer to basin edge, as you can see from this Google image. Joiner bore distance is about 12 kilometers. Shear wave velocity is about 300 meters per second. Peak ground accelerations are somewhat like 0.6 g. And peak ground velocities are higher than 1 meter per second. Especially, I would like to discuss the velocity time record of this 3124 stations Pazarcık earthquake. As you can see, there are many velocity peaks at this station. This recording is approximately perpendicular to fault direction, is approximately parallel to fault. These velocity peaks, repeating velocity peaks, but damping is effective also. Velocity peaks are probably due to basin generated surface waves.
Prof. Dr. Nihat, I think we cannot hear you, no?
Can you hear me now?
No, it is okay. Yes, yes. For sure.
I'm sorry. The sound is closing itself. I don't know why. Final.
By the way, no, it is okay. Thank you. But please share your actually presentation again. Thank you.
Okay. Can you see the presentation now?
Yes. Yes.
Okay.
Yes,
last two or three slides. Probably I'm going to repeat myself again, but sorry for the inconvenience. This plot shows the response spectra of fault parallel and fault vertical directions recorded during Kahramanmaraş Pazarcık earthquake at station 3124. As you can see, both high periods are higher than the Turkish earthquake response spectrum, design earthquake response spectrum. And this plot shows the effects of liquefaction on earthquake ground motion. Liquefaction also causes increase of periods of ground motions. Finally, main conclusions can be drawn from this study are: basin structures are very important in earthquake ground motions. They can cause response spectrum that can exceed design codes. So their geological, geophysical, and geotechnical properties should be examined, and their effect should be included in seismic design codes. Dear participants, thank you for your patience. My presentation is over now.
Thank you very much, Prof. Mokhtar Nihat, for your valuable presentation. It was interesting, and I appreciate your valuable effort. Actually, it is a time from our audience. If there is any question from their side, they can actually share their idea and they can ask their questions.
Thank you, Professor Chairman.
You're welcome. Is there any issue or any things for sharing with Prof. Dr. Nihat? Okay, thank you very much. I appreciate your actually collaboration and your contribution. It was our great honor to have you in our actually conference.
Thank you.
Thank you very much again.
Thank you.
Okay, actually, we are going to the second presentation. It will be done by Prof. Dr. Mirjana Hadzima Niarko. I hope my pronunciation was correct.
Good morning.
Actually, she is a full professor at the Faculty of Civil Engineering and Architecture, University in Osijek. Her scientific and professional fields include seismic engineering, seismic risk, and structural engineering of concrete and masonry structures. She has published more
Excuse me, I cannot hear you.
Please, can you hear me?
Yes, I can hear you now. Thank you.
I will actually give your information again. Sorry for inconvenience. Again, I would like to actually share some short information about Prof. Marjina. She's a full professor at the Faculty of Civil Engineering and Architecture, and she's working in the university. Her scientific and professional fields include seismic engineering, seismic risk and structural engineering of concrete and masonry structures. She has published more than 100 scientific papers as an author and co-author. She is a member of several scientific committees of domestic and international journals, conference organizing committees, and a reviewer for several domestic and international journals. As a leader and collaborator, she has been involved in domestic and international scientific projects. She is the co-author of 2 scientific books, Earthquake Engineering, Building Vulnerability Assessment Methods and Strengthening of Masonry Buildings, Methods and Examples. She introduced a new graduate level course, Seismic Risk, at the Faculty of Civil Engineering and Architecture in Osijek, the only course of this type taught in the Republic of Croatia. The topic that she will actually speak about is seismic vulnerability.
Sorry, I cannot hear you.
Great honor for us to have you in our conference. Please actually start your valuable presentation.
Thank you very much. I don't know if you can hear me.
Yes, we can hear
can you see my presentation?
Yes, please.
Okay, thank you very much. I would like to greet all of you present here. I would also like to thank the organizers of the conference for inviting me to hold this presentation. As we are all aware, catastrophic earthquakes hit Turkey in February this year, unfortunately with tragic consequences. In Croatia, our hearts went out to the people of Turkey who were affected by the earthquakes, since the earthquakes we had in Croatia 2 years ago is still very fresh in our minds. Today, I will present to you my research regarding earthquake vulnerability of structures. In fact, I will present some of the results we have achieved during the past couple of years working in this field. The topic of my presentation is a proposed seismic vulnerability methodology based on the calculation of damage index, that is the measure of structural damage. I will start with the definition of the earthquake risk.
Actually, we cannot hear you, Porov. I think your microphone is closed.
Yes, I don't know why.
Sorry, dear professor, I need to set before starting session. Please,
yes.
Just 1 minute. Yes, Professor, you can continue, please.
Okay, thank you. I don't know if you already heard, but I was saying that Coburn and Spence who are the most prominent researchers in the field of seismic risk assessment. They define the term.
Actually, excuse me again. Please share your file again, please.
You cannot see the presentation.
We can see you. We can see.
Yes. Yes, we can see your okay.
Dear Prof, we can see only you. Please share your presentation. I think
Okay.
internet connection is bad. Again, please share your presentation. Excuse me.
Okay. I don't know why this is happening.
No problem. Sometimes we see this problem if internet not good.
But I think it is a problem, technically problem on our side, because everybody went up.
Okay, can you see now?
Yes, now we can see. Yes, Paul.
Okay, thank you.
Actually, continue.
So Coburn and Spence defined risk as the expected losses from a given hazard to a given element at risk over a specified future time period. It can be measured in terms of expected economic loss, numbers of lives lost, or the extent of physical damage to property. Since we don't like definitions, we like mathematical formula more. I have provided you also with a simple formula from which you can see that the risk is the product of hazard and vulnerability. Vulnerability can be defined as the degree of loss caused by an earthquake of certain intensity. We like to express it in numbers, so it can be expressed on a scale from 0 to 1, where 0 means that the structure won't be damaged after an earthquake, and 1 means that the building will collapse during an earthquake. When we look at the formula, we can say that risk is high if the hazard is high or vulnerability of structure is high. We cannot influence on hazard because it is a natural phenomenon, but we can influence on vulnerability by building safer buildings or buildings with high level of earthquake resistance. Or we can retrofit or reinforce in existing ones. My country, Croatia, is an area of high hazard. It is confirmed by the catastrophic earthquakes during the history. But also 2 years ago, 2 earthquakes hit my country. First one hit Zagreb, the capital city of Croatia. The second one was stronger, with the moment magnitude of 6.4. And this earthquake hit the central part of the country, located with an epicenter located about 3 kilometers from small city of Petrinja. Only buildings constructed in the last 10 to 15 years have been designed according to Eurocode 8, but most low and medium high buildings built in the last century made of stone or brick elements have not been constructed in accordance with earthquake-resistant design concept. For Croatia, seismic hazard is presented with 2 maps, which are accepted as a part of the national annex to Eurocode 8. Hazard is expressed in terms of the peak horizontal ground acceleration, which is exceeded on average once in 95 or 475 years. We can see that our city is not in such a high prone zone like, for example, our coast. But looking at the map, it can be concluded that more than half of the Croatian territory, with more than 1/3 of the total Croatian population, is classified as a high-risk seismic zone. For the location of the city Osijek, we chose 7 earthquakes from the open database, Pair Ground Motion database. The details of the selected earthquakes are given in the table. The shear velocity corresponds to the type of soil of our location, and the peak ground acceleration of chosen earthquakes is around 0.1 g, which corresponds to the PGA for the location of the city Osijek for the return period of 475 years. The main part of this research is seismic vulnerability assessment method. Vulnerability assessment methods can be divided into 2 categories, empirical or analytical, both of which can be used in hybrid methods. Empirical or observed assessment methods are based on the observation of damage suffered during past seismic events. Analytical methods give response of a particular building representative of a typology by using structural analysis techniques and numerical tools. Our methodology is based on hybrid method, which is based on nonlinear inelastic time history analysis of the structure, which is represented by the single degree of freedom system. But our method is relatively fast, and it could be easily applied to the large number of buildings. Usually, in literature... Hello? Is it everything okay? Usually, in literature, the problem of structural damage is solved by calculating the damage index or damage ratio coefficient calculated for the structural element partial or for the whole structure global. Damage indices in various models are based on maximum values of structural response parameters or cumulative values and summing of nonlinear deformation cycles. Based on some known damage model, an original formula for damage index is given. The damage index defined by Professor Moric in 2002 is defined as the linear combination of plastic deformation, stiffness degradation, and energy dissipation of a structure during an earthquake. In the formula, you can see that D represents the displacement ductility demand, delta K is the relative degradation of stiffness at the end of the earthquake, and is the number of yield excursions reached during an earthquake, and the last part is the hysteresis energy per unit of structural mass dissipated during an earthquake. Its main function in the damage model is to describe the condition of a structure after an earthquake. The damage index values can be implemented in pre- or post-earthquake damage analysis by relating the damage index values with the values of damage level identification according to European macroseismic scale. You can see the proposed seismic vulnerability assessment methodology. Regular structure is a plane symmetrical buildings with constant vertical stiffness, and it can be interpreted by the single degree of freedom system as a mathematical model of the structure. Seismic response of structure is possible to interpret by dynamic time history calculation, where the earthquake is given as a digital time function of ground acceleration. Results of each phase calculation are included in previously explained expression for damage index. If this process is repeated for a set of SDOF systems for which the fundamental periods are changed, the obtained values can be displayed in so-called damage spectrum. Damage spectrum displays the dependence of period and the value of damage index. How can we use a damage spectrum? For a real building, we need to calculate its fundamental period. For the calculated fundamental period, we read the damage index for the chosen accelerogram. In this research, we implemented the proposed methodology for one of the city block of the O6 city. I use this opportunity to introduce you with my city and invite you to come and enjoy this beautiful city. Buildings from the city block Vienac Ivanace Smičkog were selected for the described seismic vulnerability assessment methodology. These buildings were built in 1975. They have 5 floors, and floor structures are made from reinforced concrete. The structural type of these masonry buildings is confined masonry. The most important step is to define the parameters of SDOF model. For post-elastic stiffness, it is assumed that it is 0. This assumption is based on the following findings. Due to the lack of post-elastic stiffness of masonry structure, the elastic perfectly plastic behavior is considered as a post-elastic branch. We used in this study 2 models. The first model with yield-based share of 10% of the total weight, and the second model, the yield-based share of 20% of the weight. This was done to observe the effect of yield-based share on the level of structural damage of the buildings. For the defined parameters of SDOF systems model, the selected and selected accelerograms, a nonlinear dynamic time history analysis was performed using the software Nonlin. So the program Nonlin implements step-by-step time history numerical integration, thereby providing the results of each phase. Time history displacements response of a structure, base shear displacement hysteresis, number of yield excursions reached during the response, cumulative energy balance, and displacement ductility demand. These structure response parameters were input into a previously given formula for damage index. Damage index calculations were repeated for a set of SDOF systems with a wide range of fundamental periods for 0.05 seconds to 2 seconds in steps of 0.1 second. There are presented 3 damage spectra for the SDF model with the yield-based shear of 10% of the weight. For the selected buildings, we read the values of damage index for every earthquake and give the average value. These values were read for the fundamental period of building, which was calculated using the relationship fundamental period and height, using the formula which is adopted in the Croatian National Annex to Eurocode 8. The table also present values for the second model with the yield-based shear of 10 and 20% of the weight. We can see how big is the influence of the yield-based shear on the level of structural damage. This prompted us to start a new research, which is the determination of yield-based shear for masonry buildings and confined masonry. And for the conclusion, I can say that in this paper, an assessment of the seismic vulnerability of a confined masonry building was carried out. The assessment of seismic vulnerability was based on the calculation of damage index, which is based on the linear combination of structure, plastic deformation, stiffness, deterioration, and energy dissipation during an earthquake. A set of 7 earthquakes was selected for the confined masonry buildings of a selected building block in the city of Osijek. We provided a series of nonlinear dynamic analysis of SDF system with defined input parameters, and then we constructed spectral functions of damage indices. In this study, the effect of yield-based shear on the building damage degree was investigated. We can see that for PGA values of 0.2 G, the building with yield-based shear of 10% of weight would suffer heavy damage. For PhD of 0.2 G, the building with base shear of 20% of the total weight would experience insignificant damage, but the average value of 0.29 is close to the moderate damage state. So we concluded that the value of yield-based shear has significant influence on the level of structural damage, and further research needs to be carried out in order to determine the impact of determination of the yield-based shear on the damage index values. Thank you very much for your attention.
Thank you very much for your valuable presentation. It was great, and again, thank you for sharing your valuable research with us. It is a time of our participants. If there is any issue with you and you would like to share with Prof. Marijana, we are ready to hear from your side.
I hope that you can see the presentation, the whole during the whole presentation. I don't know if the internet connection was good.
No, it was good.
Thank you.
It was actually great, and we could hear you also. We could actually watch your shared file. Your shared file.
Actually, thank you for your kind invitation. We would like to see your beautiful city. You told us about your city. I think we hope to have this opportunity to visit your city, and you also as well.
Okay, I would be very happy. Yes.
Question. Of course, we are also happy to have you in our actually conference. It was great time for us, and thank you very much again. I appreciate your actually support. I appreciate your contribution.
Prof. Dr. Inan wants to speak with you also.
Dr. Professor, we invite our university.
Thank you. Goodbye.
Also, we would like to invite you to actually come to Turkey, to Karabakh University. And also maybe next time you can present your valuable research, your valuable papers by actually face to face.
It would be my pleasure. Thank you for invitation. I hope this is only the beginning of a fruitful collaboration. Thank you once again.
Thank you very much.
Thank you very much.
Okay.
Dear Chairman Amir Hocam, can you open your voice, please?
Yes. Sorry. No, you can hear me, yeah?
Yes, we can hear now.
Or actually, yes. It is our actually third presentation. It will be our third presentation. Dr. Pakia, I hope my pronunciation is correct in this case. Her presentation around water prospecting in the dark Pound area of southern India. Spatial approach. But before starting actually from Prof. Pakia, I would like to actually give a short biography of her. She is a professor and head at the Department of Science and Technology in Chennai. She has completed her undergraduation in Bachelor of Civil Engineering at Government College of Engineering, Erode University during 1995 to 1999. Her post-graduation and doctoral research in water Center for Water Resources, College of Engineering, Anna University. She received South Asian Waters Fellowship from Wageningen University. For her research between 2008 to 2012, titled Implication of Urbanization on Ground groundwater
research interest
development. Her research interest includes water resources, development and management, advanced groundwater hydrology, hydrogeology, water quality modeling, and management. Socio-environmental impacts on water resources, water and wastewater treatment. She received fellowship under Mevlana Teaching Mobility Program from Turkey. Higher education for 2 weeks teaching program at Karabük University, Turkey during the year 2018. She presented research paper in many national and international conferences and published more than 30 research papers, peer-reviewed journals and conferences. She published a book on groundwater resources and 6 chapters in the field of water treatment options. She is currently guiding 6 PhD students. She has guided 6 postgraduate projects and 32 undergraduate projects. She received founding CIO and MOES for conducting workshops, training programs. You, Prof, to start your presentation. We are happy to have you in our actually season, and thank you very much for joining to our conference.
Thank you very much for the very nice introduction about me. Inan, my voice is audible. Is it okay? My voice is audible or not?
Yes, everything is okay, and we can hear you clearly.
First of all, I want thank you, or I want to show my gratitude to the Tekeskin and then Tulay Ekumen and the entire team, the coordinator of this event, the grand event, 4th International Symposium on Engineering Applications of Civil Engineering and Earth Sciences. It's a great one. It's my pleasure to take part in this event. Thank you for giving the opportunity, Keskin and Tulay and the entire team. Thank you for this. Shall I start? Shall I start?
Yes.
Yes. Okay. Thank you.
Yes, of course. We are ready
to hear. Thank you. First of all, I want to welcome all the participants for this, for hearing my talk on groundwater prospecting in the drought-prone areas of southern India. It is a geophysical and geospatial approach. This is my study team, myself and Melbourne, Nagamani, Anuradha, this entire team only conducted this entire case study to assess the groundwater development and for sustainable management. The sustainable management and development of groundwater sources only necessitates the clear-cut and detailed assessment, which is supported with the scientific principle and modern techniques in order to classify the regions of poor, moderate, good, and very good groundwater potential zonation. We all know the fact is water is an imperative necessity without which the human survival in the earth is not possible, not going to exist. And it acts as an integral component for the sustenance of this entire ecosystem. Groundwater resource is one among the precious and most fragile resource on the earth, which upkeeps the human health, economic development, and ecological diversity. So availability of fresh water is falling all over the world. It is also the truth. Many countries, especially the developing countries, underdeveloped countries, are affected by acute water scarcity, and most of the dreadful diseases occurring due to the unavailability of water or sometimes consumption of marginal quality of water. In India, almost 50% of urban and 90% of rural population is dependent on groundwater for their domestic requirement. Growing population, induced commercial and industrial activities, and rising agricultural demands are setting the greatest burden on the resources, and is very challenging day by day to satisfy the escalating demand along with the existing demand. So a study area is Alangudi Taluk is located at the southern part of India. The eastern portion of the particular study area is plain topography, and then western portion of the study area is the rocky terrain, somewhat slopey. It is undulating, is undergoing the uncontrolled development of. Why I am taking this particular the study area is, this area is located very near to the urban. Maybe we can call it as a peri-urban area, continuously affected because of the non-agricultural demand and non-agricultural activity. This particular village land and water resources are continuously overexploited. So this particular study area is selected for this particular research. The climate of this area is tropical. During the month of April to June is very hot and dry. Between November and January, the weather is good. The annual rainfall in this particular area is 500 mm to 1300. India's annual average is 1200 mm. It is a place that includes villages with the people. Those are solely depend on agriculture for their economy. The sole occupation is agriculture. Agriculture is predominant only during the rainy season because the surface sources are very lack. Quality wise as quantity wise is very substantial, not meeting their demand. So during rainy season only the people are doing agriculture, and non-monsoon season they are very much the economy level, everything is depending on other non-agricultural activities. This is the study area. So the entire study area is only about 77 square kilometer. Northern and western part is a riverine region. Around the riverine region, groundwater is somewhat good. Sometimes quantity wise is appreciable. Quality is still substandard. This entire area is located southern portion of India. The study area, the factors such as rainfall, uncertainties, all we know due to the climate changes, climate conditions, not only in this study area situation, throughout that scenario, national or international scenario, we are facing the uncertainty in the rainfall. Then induced urbanization is the common factor everywhere. The non-agricultural activities, absence of water conservation measures, all are causes the unsolved imbalance in this particular area. The district is also soil condition is also pathetic. Soil fertility is low. By conducting the soil investigation, the report says in this way. So the certain areas have issues with alkalinity. This could be attributed to the excess usage of the chemical fertilizer for getting the agricultural yield. The recent developments and demand for non-agricultural activities have induced the remarkable water supply demand imbalances for this area. Due to this, the research area suffers a number of issues because of the urbanized and unplanned development of water and land resources, which calls for a thorough and detailed understanding of the fragile diminishing resources. What methodology we adopted for this is for assessing the groundwater prospecting, or for assessing the groundwater, or for mapping the groundwater potential zonation. We used geospatial and geophysical techniques. The present work is targeted to map the groundwater potential zones and to investigate the prevailing status of groundwater by utilizing the advancement of geospatial techniques. Data sets such as water quality, water level, rainfall, climate, lithology, from various sources, from secondary sources as well as the primary sources, primary data, we collected along with the remote sensing data. Because we used geospatial technologies widely, it is a time-consuming, sophisticated, effective technique for delineation of different categories of potential regions, layers such as land use, land cover, geology, soil, geomorphology, and lineaments. All the maps were generated in accordance to their importance in the aspect of geopotential mapping. The general methodology applied for this study includes data collection, from the centers, state as well as central data collection centers, Indian Meteorological Department. So we used these data as a secondary sources, secondary data, and in the entire research, primary data were also collected by conducting the rigorous field investigation. So these are the general methodology. So selection of the study area for conducting this particular study. We have collected primary data and secondary data. We have used geophysical method and geospatial method for assessing, for analyzing the data. Geophysical method we are using to understand the surface and subsurface, the lithological profile. So we collected the data such as geomorphology, geology, soil, slope, lineaments, land use, land cover, hydrogeology, geophysical resistivity. These data were collected. And then we conducted, we generated thematic map. After generating thematic maps, for generating groundwater potential map, we overlaid the technique called weighted overlay analysis. So for this analysis, we ranked each parameters, influencing parameters based on their importance in the aspect of groundwater potential or recharge. So finally, the groundwater potential zonation map was created. After developing the map, we understood in the entire area, only 30% is very great, good potential. It alarms the prevailing situation, and as such, without doing any conservation, business as usual strategy surely affect the future generations. So in this methodology, in detail, we'll see the vertical VES method we used. It's very convenient and non-destructive method to collect the underground soil information and to understand the water-bearing stratum. The electrical resistivity approach has been effective and useful in locating the water-bearing deposit at the weathered fragments and the depth of bedrock, depth to bedrock, everything we can get from this VES survey. Linear trend evaluation is executed to look at the long-term water level fluctuations. That is also very, very important. The rainfall data, water level data. These are the point values. This also integrated with the spatial data. The traditional techniques of categorizing the groundwater potential zones in this particular study area is highly challenging and time consuming. While mapping and classifying the groundwater potential zone with the geospatial technology is very convenient and time consuming. Very effective, not time consuming. Information regarding these factors related to the groundwater movement, occurrence, the data such as geology, land use, all the factors were collected with a combination of satellite data. GIS system is a powerful technology. In this technology is widely used in this study. It is very useful in the delineation of groundwater prospect and to find out the deficit zones. The same set of the methodologies, the same assessment methodology is utilized by various researchers. So detailed the literature survey were also made to find out the importance of, to understand the importance of the study, otherwise literature and also the research gap. Hence the present study aims to describe the drought scenario, status of the groundwater level fluctuations, and the complete hydrological setup in this particular study area, and for mapping the groundwater potential zones. By using this overlay technique, the entire study widely utilized the geospatial technology. This is a geology map. So groundwater has occurred throughout the region as a result of various geological formation. The important factors such as porosity, permeability are actively managed by the various lithological formation. In general, in this particular study area, covered with Kadalur formation, that is weathered sandstone, the layers, confined with the impervious clay bed, which gives that formation of development of many artesian wells. With respect to geomorphology setup in this particular study area, we could see that a number of that riverine region, active floodplain, pediment, pediplains in this particular study area. The gently undulating plains of the pediplain are covered in the weathered material. That is ideal for this plain of leveled ground, moderately leveled ground is good for groundwater recharge rather than steep slopey area. It is classified as moderate because it is primarily consists of hard rock that serves that hard rock and underlined with clay zones offer the runoff than the recharge. The best landform for high groundwater potential is an active floodplain, and then the riverine zones because it has a higher water level surface. So these are the lithological detailing. We have selected 3 lithologs. The LL1 is the northern part of the study area. LL2 is the southern part. The central part covers LL3. Aquifers in the porous formation can be classified as shallow aquifers with the water depth 100 meter below ground level, and for deeper aquifers, water depth may be in the range of the 100 to 450 meter below ground level. The lithological profiles LL1, LL2, and LL3 we have selected to understand the geological and hydrogeological setup for this particular study area. In the study area, rocks referred to as weathered and fractured sedimentary formations. It also gives, because of the primary and the secondary porosity, it is also having appreciable groundwater recharge and potential. So lineaments is also act as a conduits for the groundwater occurrence and movement. Although the lineaments have been identified through this area, throughout the area, those in the pediplain are active pediplains. So the two major things are there: pediplain and active floodplains. Active floodplain considered as a very good groundwater storage thing when compared to pediplain, because pediplain is covered with rocky and then clay formation. Then soil is throughout the areas covered with alluvium zonation. In alluvium area having very good groundwater potential than the fluvial formation. When this loose alluvial material is deposited prospects, good prospects for groundwater recharge, while the open scrub has poor groundwater potential. Residential areas, generally residential and open scrubs, these areas have impermeable surface. The residential area may be covered with concrete, impermeable concrete surfaces, which offers very less recharge, greater contribution for runoff. And then slope map is western part, the study area, western part covered with a steeper slope than the eastern region. So runoff is directly proportional to the slope, we all know. So groundwater reaches will be lower on the steeper slopes, contributes more runoff. The different classes of slopes are nearly level. This -65 to -69 is a somewhat plain ground. It's the green color shades are moderate or plain ground. The red color shades are the steepy slope. So finally, the groundwater potential in mapping, that eastern part, that southern eastern part having very good potential when compared to western part of the study area. These are the land use map. These are the one of the important layer for the development of groundwater potential zonation. Various types of land use patterns are identified in the study area, such as agricultural land, vegetation, water bodies, residential areas, and open scrub. And then, meanwhile, we collected the water level data from the data centers, that is second water government wells. From the sampling wells, we collected water level to understand the monsoon fluctuation, water level fluctuation, as well as non-monsoon fluctuations. So by inferring this entire data, non-monsoon fluctuation, water level fluctuation during non-monsoon season is greater when compared to monsoon season. Water level data collected from during the period May 12 to May 20. Generally, May month is peak hot non-monsoon season, and then December, January considered as a monsoon. So May data, January data has been collected from the year 2012 to 2020. So May, Jan, again May. So we have collected, we assessed the monsoon fluctuation and non-monsoon fluctuation. So non-monsoon fluctuation during that non-monsoon area, that period, fluctuation is very deeper, greater. It is very important to take into account that the status of groundwater aquifers with respect to quantity and quality while investigating the groundwater potential. So the significant non-monsoon fluctuations, it alarms the consideration of conservation measures in this particular study area. So finally, after collecting all the data and putting into the geospatial GIS platform, the data collection, both primary and secondary data sources, and then we all arranged and analyzed in the geospatial platform. Finally, by conducting the overlay technique, the groundwater potential mapping were developed. The weightages were calculated using the scores for different classes of detected map layers. The expert opinion and similar investigation conducted by the various researchers. We used that backup for assigning the rank for each layer, the layers such as slope, soil, geology, geomorphology, lineaments, land use, rainfall, depth to bedrock. So based on that, overlay analysis were made. The grid cell with the highest values regarded as the most desirable cell, as it is located in a zone with a appreciable and good groundwater potential. Less permeable and low hydraulic conductivity zones are defined as urbanized pocket with a low recharge potential. Groundwater occurrence and flow are influenced by main groundwater storage and the controlling elements we all know. The study revealed the significant spatial variability while preparing the groundwater potential zonation, we understood. This variability was closely related to the variability in the investigated areas, geomorphology, land use, and elements. Because of this active floodplains, the eastern part of the study area is having very good and greater potential. The southern region of the study area comes under high and favorable potential zone. And also this zone only highly occupied for agricultural purpose. The western and eastern part of the study area are dominated by the rocky terrain, steep slope. So it have a moderate to poor potential zonation. The northwest portion of the study area, which is involved in the commercial development of groundwater. So it alarms the present situation and should be protected from the uncontrolled, unplanned commercial extraction. These are the developed groundwater potential map. So that blue color indicates very good. Blue color, and then very minute small portion of that pink color indicates very good potential, and red color indicates very poor potential. So that blue color region, top northern part and southern part is a riverine region, alluvial region, complete, and then the deeper depth to bedrock shows the greater potential. And then western part of the study area, steep and rocky outcrops having the moderate and low potential. In both the national as well as the international contexts, land and water resources located on the outskirts or peri-urban areas, that is located in the peripherals of the urban region, stressed much because of high demand for non-agricultural activities. The zones with denser drainages in a given region indicate impenetrable lithology, which also causes the moderate recharge because of the runoff. The zones with less drainage, on the other hand, lithology of that permeable zones is giving good recharge and good potential zone. Groundwater development for commercial purpose, a drop in agricultural activity, and a lack of understanding of aquifer recharge, aquifer setup, all threatening the aquifer, that is static reserve base. It leads to the dangerous depletion and greatest threat for the future development and for the water rights or their water resources status is very pathetic situation. So from this study, the concluding remarks are, the entire study area, So 70% comes under moderate and low potential. Only 30% comes under very good and good potential. The furthermore, moderate, low and very low potential covers 70. Already we discussed. According to the district diagnostic study report, government reports, the selected study region comes under semi-critical zone, but without considering any aquifer setup, the present scenario, the uncontrolled development, soon this particular area move from semi-critical to critical zone. So the study urges to take prompt action to undertake some water conservation projects, not only to improve recharge mechanism, but also to prevent or protect the zone from the uncontrolled augmentation of that resource. To sustain the resource base, sure that water resources managers, officials, the government departments need to conduct in-depth study further to implement the projects and to implement the structural measures. The present study explored the prospect of development and to recommend strategies to water resources managers for adopting and implementing successful site-specific structural measures for the conservation and protection of the sources. So these are the references. Thank you.
Thank you very much, Prof, for your nice presentation with a lot of valuable information for us. Actually, it is a time for our audience. If you would like to share anything with Pakia,
yes,
please.
It's a great opportunity. Entire thing is without any disturbance. It gives a platform to share my views, to share my research experience. It's a great thing.
There is any?
Yeah, I am always grateful to Karabakh University because 2 years back.
Of course, it was also a great thing.
Yes. I know very well that Tulay Kiman and Keskin, their hospitality, it's a great thing. I need to show my gratitude in this occasion. Thank you, the entire team. So wonderfully organized.
Thank you very much. You're welcome. Thank you.
Thank you.
Thank you so much.
And I would like also to invite you in conference, the same or maybe the same conference or next event, to come to the Turkey, to come to the Karabakh University again.
Eagerly waiting. Please give opportunity.
Face to face.
Give opportunity.
We would like to. Of course, it is our great honor, actually.
Thank you.
Again, thank you very much for your cooperation, for your joining to our conference, and for your valuable, actually, information that you shared with us. And I hope to hear from you very soon again. Thank you very much, Prof.
Thank you. Shall I leave, Keskin?
Thank you.
Thank you.
So we are ready to actually hear from Prof. Dr. Markel Bilicu, I hope name. His presentation will be about most of the building typologies based on the November 26, 2090 earthquake consequences. Before starting his presentation, I would like to share a short biography of him. He is graduated as a structural engineer in 2001 at the Civil Engineering Faculty, Polytechnic University of Tirana. In 2006, he has completed the master thesis entitled Vulnerability Assessment of Facility School RC Buildings in Earthquake Engineering and Engineering Seismology Institute. And in 2015, he completed the PhD studies with thesis in assessment of typified educational facilities, buildings, masonry structures. He has been a full-time scientific research engineering of Seismological Institute, Academy of Science, Albania. From 2009, he is a lecturer in the Structural Mechanics Department and Civil Engineering Faculty of Dynamic of Structures and Earthquake Engineering. During 21, actively involved in different research and academic activity in engineering, Eurocodes, and risk assessment. He has participated in different national and international research projects, many local and international conferences and training activities, as well as he has published different scientific papers and books. Latest activity are related to assessing retrofitting of damaged structures after the November 26, 2019 earthquake, border national and local seismic risk assessment. If you are ready, we are happy to hear.
Do you hear me?
Yeah.
Thank you very much. Do you hear me?
Yes, we can hear.
Yes, I can hear you, and I
hear
can
me?
also see your share.
Hello? Sorry, can you hear me?
Yes, I can hear you.
You and we can also hear you. Please, yeah, please start.
Can you hear me, please?
So we are ready to.
Sorry, do you hear me?
I think our organization committee should actually, and I think the prof cannot hear us. I think so, but I'm not sure.
Yeah.
Please.
I hear you, but can you hear me now?
Yes, I can hear you. Yes.
Thank
no,
you very much.
It is.
See the presentation, I think.
Yes, you're welcome.
Thank you.
Yeah, you can start. You're welcome.
Thank you. So thank you for the invitation for such important event. And today I want to share with you some of the aspects of the earthquake of 2019 in Albania. And during this time, I saw that there are a lot of common things that we saw during the consequences after the earthquake in Albania, of course, in smaller scale, but with those that happened in Turkey in the catastrophic event during the earthquake of this year. So I take the opportunity to express my condolence for all losses in Turkey and being there to help as much as possible to go further with this tragic event and as soon as possible to finish their consequences. So turning back to my presentation, it will be related with some of the building typologies that cover most of damages in Albania during the 2019 earthquakes, and those are three buildings typologies, different typologies. Two of them are mainly typified, constructed all over country and found even in the affected area, and the third one is related to non-engineering buildings constructed after the 90s, and with each other they have a lot of commons. And finally, we'll be focused even to some findings and recommendations. Starting with both earthquake, I learned even previously the other presentation and totally agree about some effects of the earthquake that we need to pay more attention. Both earthquakes in Albania, the earthquake of November 2019, have been also another foreshock, let's say, at 21 September, with lower magnitude, but coming to spectral values from the graph, we can see that we have almost the same spectral value for both events. So in September in Tirana, in the capital city of Albania, and November in Durrës, we face the same peak ground acceleration value, as well as the same spectral acceleration. But of course, November earthquake has a large range of long period acceleration. So you can see here that even, unfortunately, we have only 50 seconds of records, but even with such short records of that event in Durrës, again, spectral acceleration values exceed what the code maximum acceleration values are given to the code, which is the maximum spectral elastic response spectrum given by the code for Durrës area. So what it seems that basin effect maybe happen in Durrës in such areas where a lot of damages has been observed. Only to have a comparison, because I need to give an impression that, of course, the Turkey earthquake have been huge, even in spectral acceleration value. Only to have a comparison, you can see here that the Durrës earthquake has been with much lower values, but for some period range, of course, this basin effect again still gives such considerable values and affected much more flexible structure. Here it is also another earthquake hit north part of Albania in Montenegro, and you can see that even in that case, the acceleration value has been considerable. Coming back to what type of effects have been observed in Durrës after the 2019 earthquake, there are different sites with different patterns of damages. So in Durrës area, where very soft soil exists in different zones, reinforced concrete structure are mostly affected and damaged, whereas unreinforced or masonry structure or large panel concrete building suffer only few damages. In capital city, in Tirana, Vora and Kruja, other region near to epicenter, only masonry buildings suffer moderate damages. But of course, we have also another zone in north part of Tirana or Durrës, where Itumana, where several masonry buildings suffer heavy damage, some of them even collapse. So there is a part there that we saw the effect and unfortunately even the fatalities of the earthquake. But what is most important to emphasize as finding in this point, in Durrës effect, we have such areas where shear velocity of the is less than 180. So some special category of soils are found in Durrës. Those observed even with specific study, and the graph here explain that these are the shear velocity until 50-meter depth where we have the station and the registration has been done. Coming back to consequences of the earthquake, 51 fatalities and happened, and more than 90 injuries, and in total 70,000 people were displaced. The total effect of the Durrës earthquake have been around €1 billion, and 70% of that is related to the housing sector. So related to the fatalities, 24 of them are related with Durrës area and 20 others with Tumana area, where masonry buildings here and reinforced concrete buildings in Durrës. But which is important is that all important to emphasize that those fatalities as well as collapses are related with some specific structure that we're going further to deal with them here. So 33 fatalities due to the partial or total collapse of typified masonry and reinforced concrete buildings, and 13 fatalities due to the collapse of non-engineering buildings having different issues that we are going to focus in the future further. So 3 buildings or 3 typology are summarized here. Only 2 masonry buildings collapsed in Tumana are one model designed and constructed starting from year 70. It is masonry model. There are some irregularities in plan. Failure mechanism is partial collapse, and what is important that previous event of September 21 caused in that building damages, which are not considered, and so the second one caused their collapse. The second group, there are reinforced concrete frame buildings. It is another model spread in different areas in Albania. 2 buildings again collapsed, 9 fatalities. And regarding to the building characteristics, there are irregularity in elevation and failure mechanism, soft story, and further pancake. And of course, non-engineering buildings in four units. There are 13 fatalities, and again, irregularity in elevation and soft story pancake mechanism has been found in many of them. Here you can find even some information regarding to structural and other characteristics of those 3 analyzed buildings. Starting with the masonry buildings, unreinforced masonry buildings, you can see the damages happened during the November earthquake, their partial collapse in Tumana, but also damages observed in other areas like capital city or around areas. Vora is another city near to capital city where moderate to heavy damages has occurred. But all collapsed, partially collapsed buildings are situated in the region of Tumana, in the north part of capital city. But it's also some specific that I need to share. 4 buildings are heavily damaged in Tumana, but 2 of them have collapsed, and only in those buildings we faced fatalities. So the number of those buildings is really limited, but anyway, the effect is enormous. Coming to and discussing for some structural feature, the typified Urma buildings was created first in 72 as model and then improved in 77 with some architectural enhancement. But the second model has also some slightly higher structural irregularities. Although the code, seismic code of 63 does not permit irregular layouts in areas with seismicity intensity 7 or higher, this model still are found in different areas of Albania. The April 1579 earthquake provides significant understanding of the primary materials used in this building, mortar, bricks, and the weak bond between them. It also gave performance data of the building layout, including plan irregularities and out-of-plane behavior of masonry walls. After that event in 82, this model 77.5 was improved for use in seismic areas by confining somehow the buildings, adding columns, adding tie beams for slabs, but also increasing the mortar strength. And it's important to mention that mortar strength, it is increased differently for clay bricks and silicate bricks that we have both in Albania because of this bond between silicate bricks and mortar. But I need to emphasize that although these improvements are done to this upgrade model of 82, still it is not been found any trace that these findings have been implemented in the building stock constructed already in the time. And again, going further with such some structural characteristics, you can see the layout of the building, and it is composed with 2 units, Unit A and Unit B, as structural units, but connected together by a connection unit, let's say, but much more weaker because of not low percentage of transversal wall, high potential of our out-of-plane failure, stair shaft, and weakened walls for opening and windows. So Pearson's spandrel has not been strengthened in that part. Also, the prefabricated slab panels placed in one direction without tie beams also affect the joint work of the main units A and B. So the plan irregularity, the weak connection unit, and the distribution of the masonry walls lead to non-uniform deformation and increased intersection between those units, together with inadequate shear capacity of the masonry wall, as the lack of the rigid diaphragm effect of the slabs have contributed to heavy damage and collapse of, firstly, this connection unit, and after that, in 2 of buildings, also the small units B has suffered collapse. So if we are going to divide, the damage pattern appears to this model, diagonal cracks in masonry walls, especially in piers and spandrel, moderate to heavy damages of the masonry. In the upper floors, low normal stresses, disconnection of the slab panels, out of plane failure, as well as in some cases even parapet failure. In Tirana, unfortunately, this effect caused one fatality. Even the structure has no considerable damages. The factor increasing the damageability or the vulnerability of this model is the mortar strength and the bound connection between silicate bricks and mortar. In plan irregularities, vulnerable units between the main structure, out of plane failure, masonry walls length even more than 10 meters in some cases, one-way prefabricated slab and the absence of the tie beams, intervention without verifying the existing capacity. We found in several cases opening in the ground floor and also some lateral opening for adding area to extend the area. But also workmanship, many buildings have been starting by voluntary workers in that area in that time, and as well the environmental factor, deterioration and mortar quality has enhanced those damages. The second, only to finish, because even analyses are provided in order to compare the effect faced previous year after the earthquake, but also to model and to see the comparison. So comparing providing a demand spectrum related to records in Tirana, because somehow the distance of Tumana and Tirana are approximately the same with the earthquake, we create a demand spectra in order to make the comparison between demand and the capacity, and considering the characteristic of the buildings as well as the material properties. From the analysis, it has been shown that target displacement gives us information that the buildings suffer heavy damage but not collapse, and that happened in Tirana. Maybe other factors, but for me, the damages caused by September or previous earthquake has anticipated and contributed also that in Tumana we do not have heavy damage, but unfortunately collapse of those buildings. The second typified building that I need to mention is related with some reinforced concrete structure, frame structure, spread it again in different areas in Albania. But what have in common that those buildings in Durrës area has been all affected. So heavy damages happen to all of those buildings, in some cases collapse. This model was used even previous to 82, but in most of cases as layout with to masonry structure and only with 3 floors and as reinforced concrete structure. It is proposed in 82 as 5-story model, but at the beginning as prefabricated reinforced concrete frame to use in areas with high seismicity. But technical office in Durrës municipality in the time decided to provide new design, not implementing or not constructing the model as prefabricated, but making it cast in place. And the main difference between those two models are concrete cubic strength. Of course, it's understandable that concrete strength is higher in prefabricated structure, but still again, using less concrete strength, they increased the reinforcement area from 1 to 2, more than 2% of reinforcement. But still, this model earthquake shows that it is high vulnerable and with heavy damages. So in both these cases, 2 buildings collapsed. you can see the both have soft story mechanism, but the first one provided after soft story even pancake, and I'm going to explain why that happened. So this is the layout of the building, but model 82.2 has some irregularities that we need to understand. Ground floor at least 1 meter higher than the other floors. The longitudinal reinforcement of the column is being reduced significantly above the ground floor, and infills exist only partially in ground floor. Often this floor is used for services, so again, still the irregularities in elevation is increased. From the layout, it is seen that the building is irregular, but you can see here that the longitudinal reinforcement is significantly reduced from ground floor to the first floor. Some modifications are done even to those cast-in-place building, and here it is found that in one case, when we have this pancake collapse after soft story mechanism, you can see the red area. It is the original design. But what happened during the last years of 80s? They proposed a new model with extended area, and that it is done in design without any significant changes to the design. And still again, the building not only increased the surface, but during the time they added also, in this case, one floor and another half floor, let's say 1 to 2 floors added above. So the total area of the building was increased almost by 80 to 90%, and the capacity, of course, is totally reduced. And here you can find some elements of those main effects of the earthquake, and you can see that different aspects related to concrete quality and the construction details are lacking. And of course, we have crushing as well as total damage of the columns, mainly in the upper part of the columns, because our previous code considered as critical region, but also for some rebar placing, only the bottom part of the column. So it is much more dense, the reinforcement in this area, not in this case, because you can see that, again, plain rebar are placed there, single hoops, bended not more than 90 degrees. So it's a problem in any case. And you can see low confinement ratio, less splicing in critical region, and low concrete class and poor concreting in those cases. Damage and collapse are connected with various issues. Cast-in-place buildings for residential purpose began in early 80s, and the experience regarding their seismic behavior have not been comprehensive. Most of the damaged buildings during the earthquake of April 1579 have been masonry structures, so the experience is much more related to those buildings. Still, KTP 78, Seismic Code of 78, gives only few criteria for seismic detail of reinforced concrete building. Moreover, even in those cases where such details are given, the cast-in-place quality, concrete quality, and reinforced concrete element details appearance didn't result as required in those designs. The longitudinal direction, that is one of the features that it's interesting in this case, that longitudinal direction is more vulnerable, and soft story mechanism has happened in that direction. It is also shown by design. So damage patterns that are mainly appeared in this model, damage is mainly concentrated in the ground floor, joint failure at the top of the ground floor, shear cracks in columns and beams, less in beams, crushing and failure due to high normal forces, column buckling, and diagonal cracks and infills. The factor increasing the damageability, concrete quality, and construction details, low quality strength, low rebar percentage, and low volume ratio of the shear reinforcement in appropriate details, low percentage of hoops and joints. That is one of the important things that we saw, and we know that in many reinforced concrete buildings, the confinement of the joint is missing. So no hoops are found in those points. But still, there are another factors: the abrupt reduction of reinforcement area above the ground floor, insufficient dimension of primary structural elements, one-way prefabricated slabs, no rigid diaphragm behavior, added floors, or increased floors area without structural verification and retrofitting, so only increasing for functional purpose. Workmanship, still, this vulnerability works is one of the main crucial points that have been previous to 90s, but it is still going on even after the 90s with this non-engineering structure that we can find around Albania. And environmental factors, deterioration endures, unfortunately, even the aggressivity of the environment. It is on the seaside city is a considerable effect. Coming to again to the analysis, we saw that the building, and it is as it is in fact, the building designed or constructed as it is designed by original drawings, of course, suffer heavy damages, but no collapse. But the building with increased area, or in some cases, even with increased story, of course, even by model, collapse. But those are two main features that we saw. The soft story mechanism is shown in the ground floor, and most probably that is the way that building, one of the building, collapsed. And this longitudinal direction having low capacity and resistance than transversal direction. The last building, it is not a typified one, but they have a lot of common, especially indoors area where reinforced concrete are found. So that it is a traditional design and construction with these elements, but anyway, they have a lot of it in commons in number of stories, around 2 to 5 stories, type of structure, and a lot of other elements. But you can see here only a portion of that suffer heavy damages, also collapse, many soft story mechanism in Duras area. The non-engineering buildings, engineered buildings, are constructed after 90s, either with partial or without design documentation. The variety of this building is high in Duras area, where the heaviest damage or collapse occur. Their flexible reinforced concrete structures, slender columns, shallow beams, infills, and cantilever volumes in the upper floors, open ground floors. Predominant failure mechanism, as I mentioned, soft story. Still, here you can find that insufficient stiffness and resistance, poor material quality, open ground floor, so increasement of the stiffness in the upper floor and generating suitable condition to seismic energy to dissipate on ground floor. Added mass and separate footing foundation in some cases, which in case of soft soil brings additional damages to the buildings, to those buildings. And the analyzed building presented here is one of them, and it is a 4-story building constructed previously at the beginning 3-story buildings and added an extra floor. but it is chosen because this building suffered and a lot of fatalities happened there, and total collapse happened not during the main earthquake, but several hours later when the aftershock hit the building. But what it is important to see that maybe the owner have paid or have been warned about the capacity of the building, and there are traces of some jacketing of the columns of the building, but still they are done without any proper assessment and retrofitting. So unfortunately, even if they pay attention to the situation, still the building collapse. And related to the capacity, it is demonstrated even by the analysis that the capacity of the building is less than the seismic demand of 2019 earthquake. So still by the analysis has been shown that the damages appear in this specific cases. Shear capacity has huge effect on the collapse of the building. Almost the same are with the reinforced concrete structure, but I mentioned that damage pattern are much more related to extensive shear cracks in column walls, beams, and joints, crashing and failure, and short column failure are an extra damage pattern that are be found in these non-engineered buildings compared to other reinforced concrete frames. So the factors increasing the manageability of this non-engineered building, low quality of the material, and lack of seismic construction details, structural plan composed with shallow beams. A lot of buildings are this typology, increasing together with masonry placed in the upper floor and the open ground floor, increased the irregularity in elevation and that low capacity in plastic range, but also some added floors and increased area are also be found. In this case, there is no vulnerability workers after 19, but of course, construction team without proper qualification and expertise is construct those buildings. Coming to the end, findings. These buildings are, I'm going to summarize the findings for all of them. These buildings are located in areas with higher seismicity than foreseen in seismic code. Although seismic provision, previous earthquake have taught some lessons, valuable lessons, there are no evidence that findings have been used for the assessment and the retrofitting of existing building stock. Masonry buildings suffer moderate damages during the earthquake of September, and further November earthquake increased the damage degree, and in some cases, unfortunately, even building collapse. Different building typologies show inadequate seismic capacity as a result of combination of structural irregularity in plan and elevation, low material quality, and inappropriate construction details for buildings situated in seismic area. Interventions are performed without necessary structural verification, eventual retrofitting. The most common intervention, adding floor openings in the ground floor and lateral extension. Again, still the workmanship is one of the main elements that we found that reinforcement details are not properly placed in those structures. Coming to recommendation, typified buildings located in area with high seismic risk need to be fully assessed, and unified retrofitting strategy is necessary to be designed. As most of them are typified building, of course, a unified methodology, it will be much better in order to apply. But of course, their special instruction need to be done for specific cases where deviances from this typified structure can be found. An improved design has been drafted after the earthquake of 79 of confined masonry structure, and we need to check the performance of that building in order to use some of their elements even in nowadays assessment and retrofitting. Again, there are listed some of the elements should be in focus for the assessment and retrofitting of masonry buildings, quality of the mortar and the bond between bricks and mortar. In those cases, this is not one or two, but there are a lot of cases when this connection unit has increased the damage effect capacity of pier and spandrel. We saw it that using the same mortar, even in those weakened area, it is a problem. But I want to mention it that in critical infrastructure like hospitals and schools, they have been specific instruction to increase the mortar strength for those area of piers and spandrels. But of course, this diaphragmatic behavior of one-way slab, prefabricated slab, is found one of the important things that we need to pay attention, as well as spacing of transversal wall. This autoplane behavior has been found as well. Going further with typified reinforced concrete building, we need to verify the compatibility of the construction building with the typified model, check the material strength and primary structural element quality and the construction details, pay special attention to structural irregularity, shear capacity, soft soil mechanism at ground, but even in the first floor, the longitudinal direction capacity, the effect of infills, and the concrete deterioration and repair corrosion. And some extra information for recommendation for non-engineering buildings, full examination of the existing building with destructive and non-destructive tests are necessary, focused on structural elements, as well as filling the missing documentation. Assessment of damage degree in case where building have been hit by previous seismic events. A starting point, it will be good to have in the areas when earthquake hit it, like Doers areas, and check the structural system in respect to the soft soil condition and failure mechanism, especially soft story type. So thank you very much. That is what I summarized about this lecture, and I again want to thank you very much for this opportunity.
Thank you very much, Doctor. It was for us to have you in our actually conference. It was a nice presentation and with valuable information, sharing your research with us. I am happy that we have almost about participants in this. So it is a time for or any. We are ready to hear from them. To have any discussion or any.
Close. Please use my microphone.
Okay, if there is not any question, I would like to express again my special thanks to you, Paul. Thank you for actually your contribution. Also, I would like to appreciate the help from your side. Also, I would like to thank to all of our valuable participants. Yes. Thank you very much. Thank you for your supporting. Thank you for your contribution and for your cooperation.
Thank you again. It was a nice opportunity even for me to share the information, and thank you again for this opportunity.
Thanks a lot. Have a nice day. Actually, I would like also to express my thanks to all our participants. Thank you for joining to this season, and I hope to see you again in our next season. And have a nice day to all of you. Thank you very much.
Yes.
Yeah, how are you?
I have to give information, Hocam. We are closing the session. You can enter the session. The next session will start at a specified time.
Arkadaşlar, sempozyum yarım saat saat 13'te session 3 ile devam edecek. Şimdi bu oturumu kapatıyoruz. Yaklaşık 15 dakika sonrasında tekrar oturumu session 3 ismiyle yeniden açıyoruz. Bütün katılımcılarımızı yeni açacağımız oturuma bekliyoruz arkadaşlar.
Sayın Hocam, session 4 olacak. Session 4 açıyoruz.
Yalnız